Okay, are we back? Can I hear? Yes, we're back. Right. Fantastic. Right, now, luckily all this still exists here. Because I'm using Tmux, and Tmux doesn't care about the entire graphical interface being replaced with a new one. Okay, fantastic. Let's start again. Sorry about that. Luckily, nobody was watching that failure. Well, not really a failure, just beta software doing beta software things. And you can see down beside my face, I think it's right here. I'm gonna wait until I can see them. It's right down in that direction. KDE Plasma 6.2 dev. This is a dev version. This is not the normal behavior of Plasma. Probably not the normal behavior of Plasma without my changes. Anyway, right. I think we can continue. Maybe. Just going to double check I can hear myself. Yes, I can. Fantastic. Gonna have to replace the chat room anytime. And Firefox crash. That's really kind. Well, okay. Today may be a let's not continue day. Let's cut this out so I can try and get this working again. That was copy paste was the issue. I don't know exactly what I did. I understand and want to participate. Don't know why, but that's the thing today. Okay. Here we go. And our live chat from YouTube, just in case. Hello! I am so glad he didn't come in early, or at least I hope he didn't. I've been having some major issues with this. I'm sorry for that if you have. That must have been quite frustrating to watch. Anyway, it seems to be all good nowadays. I'm glad you're in here, Sorbet. Okay. I'm just gonna start rereading this in Scratch because I got angry and kind of forgot what was going on. Ah, good thing, good thing. It was a very frustrating start. Everything was broken, but as I said before, I'm on a dev version, so kind of my own fault. Right, working with environment variables. So I'm just going to start from the top. We'll improve minigrep by We'll improve minigrep by adding an extra feature, an option for case-insensitive searching that the user can turn on via an environment variable. We could make this feature a command line option and require that user enter it each time they want to apply, but instead making an environment variable, we allow for users to set the environment variable once and have their searches be case insensitive in that terminal session. Writing a failing test for the case insensitive search function. We'll first add a new search case insensitive function that will be called when the environment variable has a value. We'll continue to follow the TDD process, so the first step is again to write a failing test. We'll add a new test for the new search case insensitive function and rename our old test from oneResult to case insensitive. To case sensitive. To understand the difference between the two tests as shown in listing 1220. Right? So simply here we are going to go to where we had previously put up oneResult. We are going to change that to case sensitive. Fantastic. And after that, we are going to create a new test called case insensitive. it will be called case insensitive. Function case insensitive. Within this, that is not how you spell insensitive. I don't care. That's close enough for my usage. Let the query, let the quirks equal Rust. We're going to make it SpongeBob themed Rust. I'm going to go the exact opposite of them because I'm different and better than them in every believable way. Let contents equal, and the contents we will place inside will be the same as before, I think, right? If it's case insensitive, this will have the same behavior by the query. Yeah, it is the same thing, so that's fine. What's wrong? No, that's never used. Assert equal evac Rust and trust me, I think that's about good. Equals exactly search case insensitive with query and contents. Nope, there we go. I believe that's correct. All right, let's create this. I believe that this will. Is this a code action I can do? Inline macro. No, I don't want that, right? Can't just tell it, hey. We have a just create a public function up top. Some languages will actually allow you to do that. I quite like when they do that. I really think I'm misspelling insensitive, but I don't have the mental fortitude to check. I hope that annoys everybody listening. Right. Note that we've edited the old test's contents too. We've added a new line with the text duct tape. Oh, where? Oh, we have. I didn't notice that. I'm glad that we did. It did just tell me that. Duct tape is at the end. I don't see why. Oh, because it's capitalized, it won't actually. Yeah, it won't be picked up. Alright. Note that we've edited the old test contents too. I've definitely done that. Did it first shot, I noticed it instantly. We've added a new line with the text duct tape, using a capital D that shouldn't match the query duct when we're searching in a case-sensitive manner. Changing the old test in this way helps ensure that we don't accidentally break the case-sensitive search functionality that we've already implemented. This test should pass now, and should continue to pass as we work on the case-insensitive search. The new test for the case-insensitive search uses Rust as its query. In the search case-insensitive function we're about to add, the query Rust should match the line containing Rust with a capital R and match the line trust me, even though both have different casing from the query. This is our failing test, and it will fail to compile because we haven't yet defined the search case-insensitive function. Feel free to add a skeleton implementation of what always returns an empty vector, similar to the way we did for the search function in listing 1216 to see the test compile and fail. Right, an empty vector I think can be done with just this, right? Can't you just do that? Will that fail? Function is defined here, correct. Move these extra arguments. Right, yeah, we need to bring in query. Which will be a string. and contents, which will be, well, yeah, we do hello. Yep. At which point we also need to add in, I believe, what is it? Yep. We also need to add in the original lifetime. The generic lifetime needs to be added at the beginning. What is it? It's that. This time I'm not going to mess up, and I'm not going to put a backtick instead of a single quote. What's going on? Not used. Good stuff. That'll compile, right? No, there's still some errors. Can't compare. Yeah, you know what? I've stopped caring. Unless this is somehow wrong. Don't think it is. Yeah, this is not returning an empty vector. I know it ain't returning an empty vector, but I can't remember how to return an empty vector, and I don't see a real use case for knowing how to return an empty vector. We know the test will fail, and we know why. Right? The new test for the cases, yep. The search case insensitive function shown in listing 1221 will be almost the same as our search function. The only difference is that we'll lowercase the query and each line so that whatever the case of the input arguments, they'll be the same case when we check whether the argument contains the query. Right? So we have a fairly simple thing here. We got query, which is a reference string or a string slice. We have contents, which is a reference string or a string slice with the lifetime of generic A. And we are returning. Oh, I did forget to put a return. I wonder why it still tried to return. Of vector containing. Sorry. Yeah, containing a reference with lifetime of the generic A to a string. Fantastic. Implicitly returns. Oh, yeah, I put a semicolon at the end so it wasn't actually returning anything at any point in time. Yeah, who cares? Alright, so let the query equal query dot to lowercase. Alright, so now the query should be, well, in lowercase. Why are you doing this to me? Sure, whatever. Let the new results equal a new vector. Hello? God, I am just off my game today, ain't I? That's alright, though. What are we gonna do about it? For a line in contents, dot lines, we simply want to check if line dot to lowercase contains the query. We are passing in a reference. Oops. And if so, we simply push the results the line. At the end, we'll probably just want to paste out results or return our results. That I believe is the entire thing. Doesn't look like we have an error somewhere. Contents? Cannot find content. Ah, wow. Well, that makes sense. You can't find contents. It doesn't exist. Okay. I don't see any problem with that. That should just work straight out. Let's just compile. Are we? Yeah, we are here. Cargo. Run. Oh, well, yeah, that won't run shit. Cargo test. Hello? Um, what happened? Yep, one passed, one failed, one ignored. What was the failure? All right. Trust me, did not pick up. Why on it? Okay, let's see if this is part of it. I doubt it is, honestly. Trust me is not in the contents. That is the issue. Slash n. Fantastic. That should now work. Nope. Still doesn't exist. Rust has a space in it. Of course it does. Okay. Fantastic. One passed, one failed. And there's a period. I'm very good at this, ain't I? Well, okay. Ah, there we go. Huh, turns out if I write it correct, it works. Okay. I am not doing well today, my lord. I'm missing everything. First, we lowercase the query string and store it in a shadowed variable with the same name. Calling to lowercase on the query is necessary, so no matter whether the user's query is rust, or rust, we'll treat the query as if it were rust, and be insensitive to the case, for case. Well, to lowercase will handle basic Unicode. It won't be 100% accurate. If we were writing a real application, we'd want to do a little more work here. But this section is about environment variables, not Unicode. Thank the Lord. So we'll leave it at there. At that point. Note that query is now a string rather than a string slice. Because calling to lowercase creates new data rather than referencing existing data. I didn't notice this. That's good to explicitly say thank you. Say the query is rust as an example. That string slice doesn't contain a lowercase u or t for us to use. So we have to allocate a new string containing rust when we pass query as an argument to the contains method now. When we pass query as an argument to the contains method now, we need to add an ampersand because the signature of contains is defined to take a string slice. Next, we add a call to lowercase on each line to lowercase all characters. Now that we've converted line and query to lowercase, we'll find matches no matter what the case of the query is. Let's see if this implementation passes the tests. Yes, it passed. Or yes, it did pass here. Ah, yeah, just like mine. First try. Instantly, right out of the gate, they all passed perfectly fine. Okay, two passed. That makes sense? Yeah, sure does. Great, they passed. Now let's call the new search case insensitive function from the run function. First, we'll add a configuration option to the config struct to allow case sensitive and case insensitive search. Adding this field will cause compiler errors because we're initializing this field because we aren't words difficult today. Adding this field will cause compiler errors because we aren't initializing this field anywhere again. Right? So we will have in here a new public called ignore case. It is simply a boolean. These are all supposed to be public. Why are they not public originally? Okay. Now I've got two errors. Yeah, we don't got ignore case there yet, so that's fine. We've added the ignore case field that holds a boolean. Next, we need the run function to check the ignore case field's value, and use that to decide whether to call the search function or the search case insensitive function, as shown in listing 1222. This still will compile it. No, it will not. I really hate this. I wish we went through and just add that in. Just put in 0 or something. Makes me sad to see errors. Right, so under run, we are going to add, what exactly are we adding? Yes, let results. Yeah. Let results equal if config ignore case search case insensitive with the query sorry, where was I? Yeah, config query and a reference to contents. Else, we want to search this normally with the same piece in there. Let's just grab it from here. Oops. There we go. Yep, that should work. Else. Alright, that works. Okay, now this should be replaced to results. And it should work. Huh. Result is not an iterator. Not implemented for MT2. Required for... What? Is this why it won't compile? Or did I fuck up? I don't think I fucked up. Alright, could you tell me what error I'm supposed to be looking for? No, you won't. Maybe it'll talk about that later. Is that perhaps because these could pass back an empty tuple? Or a failed okay? Is that perhaps why it's not doing this? Alright, let's read forward, see what the issue might be. Calling either search or search case insensitive based on the value in config.ignore case. Finally, we need to check for the environment variable. Okay, I don't understand. Is the error still... Where's search? I know this is likely useless. Yeah, results could be an empty vector. That's what it comes back with. It'll always come back with a vector of some course, some case, but empty tuples are fine? Empty tuples are fine, yeah. But we currently have an error right here. Empty tuple is not an iterator. The trait iterator is not implemented for empty tuple, required for empty tuple to implement into iterator. I don't see the issue here. Have we changed anything else that I haven't seen? Vig, config. That's fine. Run, public function. Right, let's sanity check. Comment this entire thing out. See if the error still exists. If we just do this. No. No, it does not. Okay, so it must be something I fucked up here. Let's go line by line and see if there's any difference. Not here. Nope. That line's fine. This one, perhaps, looks fine. Yep, that's literally the same line. Fantastic. Is it in the if? Where did I mess up? Come on. If config, ignore case. Nope. That's fine. How about here? No, that's... I did forget the... Oh, I see. It was a missing semicolon? Yeah, there were missing semicolons, but that's not the issue. This one's just an else. It's fine. How about here? Is this the same? Yep, they're literally the same line. Now it says for line in results. Print line. And then, okay, what? Oh, it's back. The error is back now. Oh, I see, I see. The issue was, I see. I see now. Oh, okay, yep. Sorry, I did find the issue. The issue was that there wasn't a semicolon, but I forgot that this was not what I wrote. That's what they wrote. The commented out section was what I wrote. And what I wrote had a semicolon when one wasn't needed, and you are correct. Implicitly returns, but it's not implicitly returning out of run. It's implicitly returning out of the let if. Thank you for that. Sorry about this. If we have the semicolon here, it'll always return an empty tuple to results. Okay, well, that's a learning lesson. And the lesson is that I hate implicit returns with a fury. I hate them. They are disgusting. I would have instantly known what I was doing if this was the contents. No, can't have that. No, the lesson is that I'm pretty tired, and I would have figured that out eventually if I wasn't so tired, I guess. Anyway, hey, we found it out now, and thank you for that, Sorbet. As always, you are the only reason this has been going on. Seriously, I'd still be back 5 chapters wondering why a single little spelling mistake was holding me back. Would have had 3 full sessions of that. Honestly, I think it would be fun. Okay, let's continue. Finally, we need to check for the environment variable. Thank God, finally is the correct word. The function for working with environment variables are in the env module in the standard library. So you bring that module into scope at the top of source lib.rs. And we'll use the var function from the env module to check to see if any value has been set for an environment variable named ignore case, as shown in listing 12.1e3. Okay, so we need to, inside of source lib.rs, use standard env. That's it. And inside of config, the implementation, with function build args, returning result. If args.length, yep, that's fine. Query, file path, and finally, let's ignore case. Equal env var ignore case. Wow. Okay, ignore case. Dot is okay. Oh, okay. So there's a What is this? Rust. Returns true if the result is okay. Okay. Well, that's okay. So this is literally just returning true if there's literally anything in the ignore case environment variable. So I could put in like, please do not ignore cases. I need cases into the environment variable. And it'll still do it. Always lovely. And I love, and by the way, if you are writing a program, never put in an environment variable so generic as ignore case. It should be like minigrep. Grep, ignore case. That way it's specific to your application. It should never be just ignore case. And you know what? I'm not even going to respect them forgetting to do that or telling people not to do that. It will be from this point forward. Minigrep, ignore case. Fast forward to in 20 minutes when I forget that, and we spend 5 minutes trying to remember. Anyway, here we create a new variable ignore case. Is that everything we do? Ah, no. No, it is not. Ah, that's nice. We have to put in ignore case here. Of course we do. Alright. Here we create a new variable, ignore case. To set its value, we call the mvar function and pass it the name of the ignore case environment variable. The mvar function returns a result that will be successful, which will be the successful OK variable variant that contains the value of the environment variable if the environment variable is set to any value. It will return the error variant if environment variable is not set. We're using the isOK method on the Rust. Wow. We are using the isOK method on the result to check whether the environment variable is set, which means the program should do a case-insensitive search. If the ignore case environment variable isn't set to anything, isOK will return false, and the program will perform a case-sensitive search. We don't care about the value of the environment variable. We just care about whether it's set or unset. So we're checking isOK rather than using unwrap, expect, or any of the other methods we've seen on result. We pass the value in the ignore case variable to the config instance so the run function can read that value and decide whether to call search case insensitive or search, as we implemented in listing 12.22. Let's give it a try. First, we run our program without the environment variable set and with the query to, which should match any line that contains the word to in all lowercase. Cargo run -- okay. Yep. So let's cargo run this. For some reason, I don't think this is going to work. To and poem.txt. Are you nobody too? How dreary to be somebody. Oh, it did work. Oh, yeah, I'm supposed to... Yeah, because we don't have the environment variable set, it'll be case insensitive, but there's no sensitivity here. So, I guess... Okay, looks like that still works. Now, let's run the program with ignore case set to 1. But with the same query too. Alright. Minigrep. Ignore case. Equals. Oh. Cargo. Run. -- to poem.txt. Are you nobody too? How dreary to be somebody. To tell your name the livelong day. To be an admiring bug. Alright, yeah, that works. If you're running PowerShell, you will need to set the environment variable and run the program as a separate command. If you're running If you're running PowerShell, I feel sad for you. I hope you get better someday. I wish you the best, honestly. This will make ignore case persistent for the remainder of all your shell session. It can be unset with the remove item commandlet. Remove item and ignore case. We should get lines that contain 2, that may have uppercase letters. Yep, excellent. We also got lines containing 2. Our minigrep program can now do case-insensitive searching controlled by an environment variable. Now you know how to manage options set using either command line arguments or environment variables. Some programs allow arguments and environment variables for the same configuration. In those cases, the programs decide that one or the other takes precedent. For another exercise on our own, try controlling case insensitivity through either a command line argument. I still don't understand what PowerShell is supposed to be. I don't think anyone does. Really, what I believe it to be is they're trying to make it as close to the Linux shell as possible without actually being any Linux shell, like Bash or ZSH. Because you can use most of the syntax. You understand that their command line structure is terrible, but they're not going to fix it, because if they wanted to fix it, they'd just use Bash. Which you can on Windows. You can just use Bash on Windows. I don't see why you wouldn't. For another exercise of your own, try controlling case insensitivity through either a command line argument or an environment variable. Decide whether the command line argument or the environment variable should take precedent if the program is run with one set to case sensitive and one set to case insensitive. Okay? Personally, I think the command line variable should be the best one. Actually, let's try that now. How are we getting command line? Are we getting that again? Yeah, arg 1, 2. You know what? I actually don't care. I legitimately have stopped caring at this point, because now I'm thinking what will I have to do. If I want, personally, what I want, if I were in this situation, I would want command line flags to be at the start. So -- ignore case would have to be here, meaning all of our stuff drifts down by 1, meaning I'd have to take some form of variable here that will add the amount equal to, you know what, we can actually do that, but then we'd have to check for the first one if there's flags, and then repeat over, you know what, actually let's do that. I've changed my mind like 3 times. My mind is not in the state to be doing any of this type of work, so honestly, I'm going to do that on my own tomorrow, when perhaps I have a bit more of my mind left to me. I'm sorry for that. I heavily suggest doing that, though. I have an idea. Is it possible to have both configured? Absolutely, it would be. Both Bash and PowerShell, or both the command line argument and the flag? Absolutely, you could. Well, that's the thing. If I did have this set, and then I passed in the argument -- ignore case, which one should take precedent? Like, in this situation, if I had -- ignore case and minigrep ignore case, this command would have both set. If I were to have like an environment variable called no ignore case, that would have this set to true, and this set to false. This is opposing. Like, one states to have it set, and one states not to have it set. And thus you'd have to decide which one to do under this circumstance. So yeah, it's absolutely possible to have both the environment variable and the flag set. And that's something you're going to have to think of when you write an application that utilizes both. Yep, I would completely agree, because currently, minigrep ignore case is set. If I were to run this right now, it would, in fact, still work as it did before. Environment variables, I think, should be thought of as defaults. If there's some conflict in the command that you actually did run, I completely believe they should be, it should be overwritten. unless the environment variable is something like, hey, never do this thing. It really depends on the use case, but in general, environment variables can be overwritten by command line flags. Oh, that's really weird. Why did the environment variable not persist? The environment variable isn't persisting. Huh, okay. I guess I'm a bit wrong on environment variables persisting, but I am using fish and not bash. Anyway, most of what I said still does stand to be true, I would argue. Like if somebody set this in their bash profile, that would be permanent. Anyway, I'm just going to continue on. If you want to do this on your own, I'm personally going to be doing this on my own. This section saying, hey, allow for the flag to be put in there. I'm sorry, my mind is just not in the right place right now. I don't know why. Okay. Writing error messages to standard error instead of standard output. At the moment, we're writing all of our output to the terminal using the println macro. In most terminals, there are two kinds of output: standard output for general information and std error, or standard error messages. This distinction enables users to choose to direct the successful output of a program to a file, but still print error messages to the screen. The println macro is only capable of printing to standard output, so we have to use something else to print standard error, checking where errors are written. First, let's observe how the content printed by minigrep is currently being written to standard output, including any error messages we want to write to standard error instead. We'll do that by redirecting the standard output stream to a file, while intentionally causing an error. We won't redirect the standard error stream, so any content sent to standard error will continue to be displayed on screen. Command line programs are expected to send error messages to the standard error stream, so we can still see error messages on the screen, even if we redirect the standard output stream to a file. You've said this 3 times now, thank you for that. Our program is not currently well behaved. We're about to see that it saves the error messages output to a file instead. To demonstrate this behavior, let's run the program with a redirect and the file path, output.txt. Now we want to redirect the standard output stream too. We won't pass any arguments, which should cause an error. Okay, I'm just going to trust them, honestly. Yeah, you know what, let's just see this for posterity, I guess. Out.txt. And if we end them /out.txt, we get nothing. Why? Why do we get nothing? I thought we were supposed to get something. Well, that's fine. Oh, this isn't compiling. Is it compiling? This is compiling. This is compiling fine. We are running it, but we don't get the error output. Not enough arguments, expects 2. Does not run. Why? Okay, that's nice. You might be missing a string a little. Thank you. What is it? What is the string literal again? I can never remember in this thing. What is the string literal? We're not using it anywhere, are we? No. No, we're not. This is incredibly frustrating. String literal rest. isn't it just... Oh yeah, we are. We're using it right here. Okay. Where were we? Yeah. I see. Okay, that's working now. Let's see how many arguments are in this thing. There's one, which is less than 3. So we return the error, not enough arguments, expects 2. Yes. Where is... Where is this? Look, fuck, hell. Why isn't any of this working? Build is being used here, but it's also being used here. Yes. Config equal this. You can also... Yes, if let error, config equal config. If it's an error, process.exit 1. We are not printing the error. Why are we not printing the error? I don't think that'll work. Sure. Okay, there we go. Alright, that's a failure from another day coming back to bite me, but that's alright. And now we have the error here. There we go. The redirect syntax tells the shell to write the contents of standard output to output.txt instead of on the screen. We didn't see the error messages we were expecting printed out to the screen, so that means it must have ended up in the file. This is what output.txt contains. Problem parsing arguments, not enough arguments. Yep, our error message is being printed out to standard output. It's much more useful for error messages like this to be printed to standard error, so only data from a successful run ends up in a file. We'll change that. Printing errors to standard error. We'll use the code in listing 1224 to change how error messages are printed. Because of the refactoring we did early in this chapter, all the code that prints error messages is in one function, main. It's right here. The standard library provides the print line macro that prints two standard error string. So let's change the two places we're calling print line to print errors to use print line instead. Right? Here and there. Right, so that's an print line, and I guess I didn't put it in here either. Why? I really don't remember doing that. Okay. Application error. Meaning an which doesn't exist in this context. Yeah, it does. Yeah, it does. The if let message here. I really don't remember messing that up. Well, why would I remember messing it? Anyway. Now let's run the program again in the same way. I'm just going to be printing to /dev/null because we actually don't care about that output. We should be just getting it out here. Right, not enough argument, expects 2. Good stuff, she works. And I'm going to remove output.txt. Yep. Now we'll see the error on screen, and output.txt contains nothing, which is the behavior we expect of command line programs. Let's run the program again with arguments that don't cause an error, but still redirect standard output to a file like so. Cargo run --to home.txt. We won't see any output from the terminal, and this will contain our results. Okay, I'm just going to believe them. No, not because I've messed up before. Alright. Let's see this, if this works. We already have this in our listing previously. So let's just... Right. Good stuff. Yep, she works. This demonstrates that we're now using standard output for successful output and standard error for the error output as appropriate. Summary. This chapter recaps some of the major concepts you've learned so far and covered how to perform common I/O operations in Rust by using command line arguments files, environment variables, and the bprintline macro for printing errors. You're now prepared to write command line applications. Combined with the concepts in the previous chapter, your code will be well organized, store data effectively in the appropriate data structures, handle errors nicely, and be well tested. Next, let's explore some Rust features that were influenced by functional languages, closures, and iterators. Okay. Right, we've still got an hour to go forward. I think that we can continue a bit for today. But I'm very excited. Iterators and closures are awesome. Let's go forward. Rust's design has taken inspiration from many existing languages and techniques, and one significant influence is functional programming. Programming in a functional style often includes using functions as values by passing them in arguments, returning them from other functions, assigning them to variables for later execution, and so forth. In this chapter, we won't debate the issue of what functional programming is or isn't, but will instead discuss some features of Rust that are similar to features in many languages often referred to as functional. You can tell that they were hurt. They were hurt quite often, and very, very many people came to them to yell at them to say that these functions are necessary for functional programming. I feel so bad for these horribly abused men. More specifically, we'll cover closures, a function-like construct that can store in a variable, that you can store in a variable. Apologies. Iterators, a way of processing a series of elements. I love iterators. How to use closures and iterators to improve the I/O project in Chapter 12. The performance of closures and iterators, spoiler alert, they're faster than you might think. And that is the last thing. We've already covered some other Rust features, such as pattern matching and enums, that are also influenced by the functional style, because mastering closures and iterators is an important part of writing idiomatic, fast Rust code. We'll devote this entire chapter to. Closures? Anonymous functions that capture their environment. Rust closures are anonymous functions that can save in... Wow. Rust closures are anonymous functions you can save in a variable or pass as arguments to other functions. You can create the closures in one place and then call the closures elsewhere to evaluate it in a different context. Unlike functions, closures can capture values from the scope in which they're defined. We'll demonstrate how these closure features allow for code reuse and behavior customization. This is going to be hell with lifetimes. I just thought about that. All of my experience with closures are in JavaScript and JavaScript adjacent stuff. So, oh my god, lifetimes are going to be hell for this. Capturing the environment with closures. First, we'll examine how we can use closures to capture values from the environment they're defined in for later use. Here's the scenario. Every so often, our t-shirt company gives away an exclusive, limited edition t-shirt to someone on our mailing list as a promotion. People on the mailing list can optionally add their favorite color to their profile. If the person chosen for a free shirt has their favorite color set, they'll get that color shirt. If the person hasn't specified a favorite color, they get whatever color the company currently has the most of. Oh, that's quite nice. There are many ways to implement this. For example, we're going to use an enum called shirt color that has the variants red and blue, limiting the number of colors available for simplicity. We'll represent the company's inventory in an inventory struct that has a field named shirts that contains a vec shirt color representing the shirt colors currently in stock. The method giveaway, defined on inventory, gives the optional shirt color preference of the free shirt winner, and returns the shirt color the person will get. This setup is shown in listing 13-1. Drive debug. Alright, so here we have simply a driving debug, partial equality, copy and clone. The enum shirt color. Are we supposed to be making this? I don't think so. Okay, this is fairly long. Let's read through this code though anyway. Alright, so we got that enum they were talking about. We got that struct inventory, which is just shirts, a vector of all shirts. Sorry, a vector filled with shirt colors. Implementing inventory, function giveaway. Takes in self, user preference, option, shirt color. An optional shirt color. So it could have a shirt color, it could not have a shirt color. Or it could have any shirt color, I guess. User preference.unwrap or else. Self.most. It unwraps or else, but doesn't do anything with the else. Just does nothing. Function most stopped, taking in self, shirt color. Yeah, so most stopped, let mutable number red equals 0, 0 for both, for color in self.shirts. So for every shirt, match color if it's red. Oh, it's like list comprehensions in Python? I'm not very familiar with Python, I'll admit. If it seems familiar, it probably is. Python's a scripting language. It seems like it would have this type of functionality, and I see no reason not to. Right, so here though, we're just matching the color, adding it up. If number of red is over blue, shirt color red, else color blue. It just returns red or blue, depending on what is most in stock. Fairly easy. Let's store equal inventory shirts vector. Here are all the shirts. User pref equals sum shirt color red. User pref 1. Alright, giveaway equals store.giveaway. User pref 1. Line the user with preference. Blank gets blank. Right, the user will get the color red because that is their preference. User 2 has no preference. The user will get. I don't know why I read through all of that. That's incredibly basic and fairly easily understandable, but hey, who knows? This is not currently using closures, to be clear. The store defined in main has 2 blue shirts and 1 red shirt remaining to distribute for this limited edition promotion. We'll call the giveaway method for a user with a preference for a red shirt and a user without any preference. Again, this code could be implemented in many ways, and here, to focus on closures, we've stuck to concepts you've already learned, except for the body of the giveaway method that uses a closure. Does it? Where? Oh, yeah, here. Here it does use a closure. Doesn't do anything with it. Yep. In the giveaway method, we get the user preference as a parameter of type option shirt color and call the unwrap or else method on user preference. The unwrap or else method on option T is defined in the standard library. It takes 1 argument, a closure, without any arguments that returns a value T, the same type stored in the sum variant of the option T, generic type. In this case, shirt color. If the option T is the sum variant, unwrap or else returns the value from within the sum. If the option T is a non-variant, unwrap or else calls the closure and returns the value returned by the closure. We specify the closure expression to var self.most. Oh, okay, yeah, I guess this makes sense. Oh yeah, you're right. You are correct. Sorry about that. I didn't read you for a bit there, but yes, that is the closure. I did forget that was there. This is the closure. This is the function that is defined within the closure, which is just self.most. This is, I guess, the syntax for bringing in a closure, with anything between the 2 bars being a variable that is passed into the closure. Alright, I don't love the syntax, but I can understand it now that I understand it's there. As the argument to unwrap or else. This is a closure that takes no parameters itself. If the closure had parameters, it would appear between the two vertical bars. The body of the closure calls self.most. We're defining the closure here, and then implementation of unwrap or else. We'll evaluate the closure later if the result is needed. Running this code prints, cargo run. The user with preference some red gets red. The user with preference none gets blue. Okay. One interesting aspect here is that we've passed a closure that calls self.mostStocked on the current inventory instance. The standard library didn't need to know anything about the inventory or shirt color types we defined, or the logic we want to use in this scenario. The closure captures an immutable reference to the self-inventory instance and passes it with the code we specified to the unwrap or else method. Functions, on the other hand, are not able to capture their environment in this way. Closure type inference and annotations. There are more differences between functions and closures. Closures don't usually require you to annotate the types of the parameters or the return value like functions do. Type annotations are required on functions because the types are part of an explicit inference exposed to your users. Defining this interface rigidly is important for ensuring that everyone agrees on the types of values a function uses and returns. Closures, on the other hand, aren't used in an exposed interface like this. They're stored in variables and used without naming them and exposing them to users of our library. Closures are typically short and relevant only within a few narrow contexts rather than an arbitrary scenario. Within these limited contexts, the compiler can infer the types of the parameters and the return types, similar to how it's able to infer the types of most variables. There are rare cases where the compiler needs closure type annotations too. Okay? As with variables, we can add type annotations if we want to increase explicitness and clarity at the cost of being more verbose than is strictly necessary. Annotating the types for a closure would look like the definition shown in listing 13-2. In this example, we're defining a closure and storing it in a variable, rather than defining closure in the spot we pass it as an argument, as we did in listing 13.1. Let expensive closure. Is this expensive? Oh, okay, never mind. Yeah, this is, okay. Let expensive closure equal taking in number, which is a U32, returning a U32, and then within the square brackets, we have the full function. I'm assuming the square brackets are not needed if it only has one singular, what is it called? I can't remember, one singular thing within it. Adding optional type annotations of the parameter and return values types in the closure. Right, could we still have, why would we not be able to have annotation within a one-line closure? I don't think there's any issue with that. Probably fine. Yeah, see, right here is fine. With type annotation added, the syntax of closure looks more similar to the syntax of functions. Here we define a function that adds 1 to its parameter, and a closure that has the same behavior. For comparison, we've added some spaces to line up the relevant parts. This illustrates how closure syntax is similar to function syntax except for the use of pipes and the amount of syntax that is optional. Right, so get a function, add 1 v1, takes in x, which is a u32, returns a u32. We have the same thing as a closure, which is just stored in the add1v2 variable. Just uses the pipes instead of brackets. I'm guessing the reason we're using these pipes instead of the brackets is due to the fact that this may be construed as a tuple of some type. Yeah, because that's an actual thing. Okay, I was wondering why the pipes, but that kind of does make sense, I guess. Right, yeah, we can have the exact same syntax, or we can not, or we can both not and not have those brackets. Would we be able to have this syntax without the brackets, though? The first line shows a functional definition, and the second line shows a fully annotated closure definition. In the third line, no, we definitely wouldn't be able to have the return, to be clear. No, we couldn't, because how would I know that X isn't simply part of this? Whatever. And the second line shows a fully annotated closure definition. In the third line, we remove the type annotations from the closure definition. In the fourth line, we remove the brackets, which are optional because the closure body has only one expression. That's the word I was looking for. These are all valid definitions that will produce the same behavior when they're called. The add1v3 and add1v4 lines require the closure to be evaluated. To be able to. Okay, yeah, the reason there was because it's poorly written, I see. Requires the closure to be evaluated to be able to compile because the types will be inferred from their usage. This is similar to let v equal vec new, needing either type annotation or values of some sort. Needing either type annotations or values of some type to be inserted into the vec for us to be able to infer the type. For closure definitions, the compiler will infer one concrete type for each of their parameters and for their return values. For instance, listing 13-3 shows the definition of a short closure that just returns the value it receives as a parameter. The closure isn't very useful except for the purposes of this example. Note that we haven't added any type annotations for the definitions. Because there are no type annotations, we can call the closures with any type, which we've done here in the with string the first time. If we then try to call example closure with an integer, we'll get an error. Example closure taking an x, returning x, let s equal example closure, string from hello, let n equal example closure 5. Attempting to call a closure whose types are inferred with two different types. Okay, so yeah, without adding in the types defined here, we can at some point set them and then have every single piece of code that calls it previously found. So if you want to mess with somebody, unless the compiler is really quite good, you could have like a 40-line function where we utilize this closure set like 10 times, and then just at the start, force it to infer to an entirely different type. At which point, from reading the code, it would be difficult without figuring out this specific line as the issue. The compiler gives us this error. Hopefully this is a good error. I don't know. Oh no, chat's gone. Oh, has the internet been gone? Is the internet gone? Oh. Sorry about that. It looks like chat just deleted itself. Also, I believe my face has been popping in and out for the entire time. But can we use generic types on closures? I don't see why not. As long as we follow the rules. Sorry, just trying to pop out chat again. I really can't see why not. I hope they explicitly state so. We got quite a lot left here, so it should. Right, let's see this error. This error looks quite nice. Right, example closure 5. Here's where we start using it. Help. Try using a conversion method to string. Expected struct string found integer arguments to this function. No, closure parameters defined here. X. Okay. Right, so this is a major issue. It doesn't tell you where it was forced to be a string. It should. I mean, it absolutely could. It has to. The first inference. Expected struct string found integer. Arguments to this function are incorrect. Right. But the parameter is not really defined here, is it? It's not in actuality defined here. This is a major issue. This will cause some frustrating errors. We have string from hello here. This is where the error is. This is where it exists. The first string here. I mean, sure. Perhaps it could, in fact, be here, but you know. This is strongly a part of it. This is where it turns into a string. This should be something it logs out. The first time we call example closure with the string value, the compiler infers the type of x, and the return type of the following closure would be string. Those types are then locked into the closure with the example closure, and we get a type error when we next try to use a different type with the same closure. Right, here's a quiz. Which of the following best describes the rationale for why Rust will infer the types of arguments/returns for closures, but not top-level functions? A, for backwards compatibility, that is incorrect. B, anything assignable to a variable can be typed inferred. Top-level functions cannot be assigned to a variable. I don't think that's why. Due to the halting problem, it is mathematically impossible for Rust to infer the types of top-level functions. I don't know what the halting problem is. Well, no, I know what the halting problem is, but I don't see what reference that has to this. Top-level functions can be part of a library's external interface, while closures cannot be directly exposed. I believe this to be the correct one. Halting problem. I do remember that, but I really don't think this is... Yeah, I think it's D. I think that's probably the, Oh, well, I can't search in here. But yeah, I think this is likely the answer. I don't see why they bring up the halting problem. Rust permits pattern matching within closure arguments, including the use of the underscore. For example, you could write the following. F underscore nothing. Sometimes called the toilet closure. Oh, that's quite cute. Let S equal string from hello. Function S. Which of the following best describes the relationship between F and S in this program? F captured S in its environment. I think that's true. F causes S to be immediately dropped. That's not correct. F has no effect on S. It does. Maybe F doesn't have an effect on S? I'm unsure. F reads S and then throws away the result. I think that is what's happening. But I believe that A is correct. F captures S in its environment. I do believe that is something that is happening in order for S to be utilized. D again? I mean, that is exactly what it does. But I don't think that's a relationship between F and S. You know what? I'm way too tired. I'm going to trust you for this. 1 out of 2 answers correct. Okay, you answered. Top-level functions can be part of a library's external interface. That is correct. Here, however, I mean, that is what it's doing. That is actually what F, the closure, is doing. But I do believe that the relationship is that F captured S in its environment. Let's see, though. I can fully understand why you got that. F causes S to be immediately dropped? Okay, I was entirely wrong on that. That is terrifying. The toilet closure is similar to standard memory drop. It throws it in the toilet, like a dead fish, i.e. a function that moves an argument and causes it to be dropped. Okay! Thank you, explicitness. Yeah! What? I mean, okay, this does make sense. Right, so we are passing S into a function. It is not even borrowing it. It now owns it. F owns S. It does nothing with S, and at the end of the function, S is dropped. It's dead. It's no longer used. It is outside of its scope, and thus is dropped. So, the toilet function kills S, and it's its only purpose. Okay. I like that. That's kind of funny. Hey, how do I drop a variable? I can't... No, just throw it in the toilet, boy. Yeah, garbage collecting. Look, personally, when I have a bunch of garbage and I need to get rid of it, I just slowly funnel it through my toilet into the city's local water distribution system. That is fun. I hope nobody does this. Please just use toilet standard memory drop. If I see this, I'm gonna think there's some weird voodoo going on. I'm not gonna remember this. I'm not gonna remember that this is the toilet and we're shoving everything in it. Why? Okay. Okay. The more I read about this, the more I love Rust and the more I hate Rust, and the more I'm terrified of Rust. Let's continue. Capturing references or moving. I'm sorry, back to this. This quiz, did they really expect us to know this? They haven't described this at all. They're just like putting this in here. Oh, by the way. Okay. Okay. Whatever, man. I'm gonna stop complaining about this. Closures can capture. Closures can capture values from their environment in three ways, which directly map to the three ways a function can take a parameter. As a streamer with more than one viewer, you should put a warning. Do not do this at home. Oh, I do have two viewers. Yeah, don't do this at home, boys. Look, I'm going to use all of my power, my vast amount of power that I have personally gained as a top-of-the-line streamer. Never do this. Look, if I see this again, I'll know. I'll know. You saw this. You had a warning. Okay. Closures can capture variables from their environment in three ways, which directly map onto the three ways a function can take a parameter: borrowing mutably, and taking ownership. The closure will decide which of these to use based on what the body of the function does with the captured values. Okay. In listing 13.4, we define a closure that captures an immutable reference to a vector named list, because it only needs an immutable reference to print the value. Right, we have main list equals a vector 1, 2, 3, print line, before defining closure. That works. Let borrows only. It takes nothing in, prints, from closure, and then a list. Okay, since it doesn't take it in, and this is simply from the original context, it is a borrow, not taking ownership. Then we can use it. We can only borrow it, and this should work. That'll all work. Let's run it. Running. I think this will all just print list every time. Yep, that's fine, because, okay, so it will usually take ownership, I'm assuming, if we do directly pass it in. But to be clear, what this is saying here is that we can use any variable within our closure that is from the from the context outside of, within which the closure exists, just to specifically state why closures are so cool. Because we could pass in only borrows and it'll still work like this. This is why closures are cool. I like closures. Right, defining and calling a closure that captures an immutable reference. This example also illustrates what a variable can bind to a closure definition, and we can later call the closure by using the variable name and parentheses, as if the variable name were a function name. Because we have multiple immutable references to list at the same time, list is still accessible from the code before the closure definition. After the closure definition, but before the closure is called, and after the closure is called. This code compiles, runs, and prints the following. Yep, she fine. Next, in listing 13-5, we change the closure body so that it adds an element to the list vector. The closure now captures a mutable reference. Let mute list equal vac123. Print, before this, she works. Let mutable borrows mutably, push 7. I think this will work fine. This won't have any issue, right? This will just do the thing that you'd expect. Add 7 to the end. Yep. This code compiles, runs, and prints. Note that there's no longer a print line between the definition and the call of the Boros mutably closure. When Boros mutably is defined, it captures a mutable reference to a list. We don't use the closure again after the closure is called, so the mutable boro ends. Between the closure definition and the closure call, an immutable boro to print isn't allowed. Because no other boros are allowed when there's a mutable boro. Okay, I think I understand. Right, yeah, so between these two things, since it is currently boro, we cannot utilize it in any other context until it drops boro, which is the last time that boro's mutably is referenced. There's so much in Rust that's just implicit that you have to just keep in your head. That's not just there. If you want to force the closure to take ownership of the values it uses in the environment, even though the body of the closure doesn't strictly need ownership, you can use the move keyword before the parameter list. The technique is mostly useful when passing a closure to a new thread to move the data so it's owned by the new thread. We'll discuss threads and why we want to use them in detail in Chapter 16, when we talk about concurrency. But for now, let's briefly explore spawning a new thread using a closure that needs the move keyword. Listing 13-6 shows listing 13-6 shows listing 13-4 modified to print the vector in a new thread rather than the main thread. Alright, so we're using standard thread, multi-threading. Let list equal 1, 2, 3. Put line before the closure, thread spawn, creating a new thread, move. Taking in an empty, not taking out anything. We simply print line from the thread, and then printing a list inside of the thread. We then join all our threads and unwrap the result. Okay, using move to force the closure for the thread to take ownership of list. Oh, okay, so the move keyword ensures that inside of a closure, or perhaps in other context, anything that would be borrowed is instead moved over. It takes ownership. We spawned a new thread, giving the thread a closure to run as an argument. The closure body prints out the list, and listing 13-4. The closure only captures list using an immutable reference because that's the least amount of access to list needed to print it. In this example, even though the closure body still only needs an immutable reference, we need to specify that list should be moved into the closure by putting the move keyword at the beginning of the closure definition. The new thread might finish before the rest of the main thread finishes, and the main thread might finish first, race condition. If the main thread maintained ownership of list but ended before the new thread did and dropped list, the immutable reference in the thread would be invalid. Therefore, the compiler requires that list be moved. So it's like at. Yeah, that's a good description. That's a very good description. Yeah. Therefore, the compiler requires that list be moved into the closure, given to the new thread so that the reference will be valid. Try removing the move keyword or using list in the main thread after the closure is defined to see what the compiler errors out as. I don't care that much, to be honest, about what it errors out as, but it's good to know. And thank you for that description. That's a really good description. I'm glad that it will give you a compiler error to tell you that there's a race condition. Moving captured values out of closures and the FN traits. Once a closure has captured a reference or captured ownership of a value from the environment where the closure is defined, thus affecting what, if anything, is moved into the closure, the code in the body of the closure defines what happens to the references or values when the closure is evaluated later, thus affecting what, if anything, is moved out of the closure. A closure body can do any of the following: move a captured value out of the closure, mutate the captured value, neither move nor mutate the value, or capture nothing from the environment to begin with. The way a closure captures and handles values from the environment affects which traits the closure implements. And traits are how functions and structs can specify what kinds of closures they can use. Closures will automatically implement one, two, or all three of these function traits in an additive fashion, depending on how the closure's body handles the values. Fn once applies to closures that can be called once, or a singleton. All closures implemented at least this trait, because all closures can be called. Sorry, I guess that's not a singleton, that's just something that can be called at least once. A closure that moves captured values out of its body will only implement Fn once, and none of the other Fn traits, because it can only be called once. Okay, that is a singleton. Fn mute applies to closures that don't move captured values out of their body, but that might mutate the captured values. These closures can be called more than once. Fn applies to closures that don't move captured values out of their bodies and that don't mutate captured values, as well as closures that capture nothing from their environment. These closures can be called more than once without mutating their environment, which is important in cases such as calling a closure multiple times concurrently. Let's look at the definition of the unwrap or else method on option T that we use in listing 13-1. We have implement option T, public unwrap or else. Self, where Fn once returns type T. So anytime it implements Fn once, which is in every single closure, it returns T. I don't understand. Alright, it just matches sum. If there's some variable of type x, it outputs x. If there's nothing, it outputs the function. Sorry, it outputs call to f. Where's the call to f? Oh, f is the closure. Yep, okay. The else is the closure. Okay, yeah, that makes sense. Sorry. Tired. Recall that T is a generic type representing the type of the value in the sum variant of an option. That type T is also the return type of the unwrap or else function. Code that calls unwrap or else on an option string, for example, will get a string. Next, notice that the unwrap or else function has the additional generic type parameter f. The f type is the type of the parameter named f, which is the closure we provided when calling unwrap or else. Where? The f of type f. Yeah, but that's... I don't care. The trait bound specified on the generic type f is Fn once returning T, which means f must be able to be called once. F must be able to call once, takes no arguments, and returns a T, anything that is the original type. Okay, I think I understand. Using Fn once in the trait bound expresses the constraint that unwrap or else is only going to call f at most one time. In the body of unwrap or else, we can see that if the option is sum, f won't be called. If the option is none, f will be called once. Because all closures implement Fn once, unwrap or else accepts the most different kinds of closures and is as flexible as it can be. Accepts the most different kinds of closures. That is not proper English. Who cares? Functions can implement all three of the Fn traits too. If what we want to do doesn't require capturing a value from the environment, we can use the name of a function rather than a closure where we need something that implements one of the Fn traits. For example, on an option vec t value, you could call unwrap or else vec new to get a new empty value if the value is none. Oh, that's quite cool. So that can just take a regular function call without being a closure. It's Pride Month. We accept all closures? Absolutely. Ugh. Now let's look at the standard library method sort by key defined on slices to see how that differs from unwrap or else and why sort by keys uses fn mute instead of fn once for the trait bounds. A closure gets one argument in the form of a reference to the current item in the slice being considered and returns a value of type k that can be ordered. This function is useful when you want to sort a slice by a particular attribute of each item. In listing 13.7, we have a list of rectangle instances that we use sort by key to order them by their width attribute from low to high. Right, we have struct rectangle, width and height, let mutable list equal bunch of rectangles, list.sort by key, and then we just have a function, a closure, taking in r, which is a rectangle, returning r.width. Current line, I can't remember what all that means, but hey, it prints out list. Using sort by key to order rectangles by width. Oh, sort by key. I guess that's just, hey, this closure is simply the function to get the value that we are sorting by, to get the key that we are sorting by, which will be r.width. Okay. Code prints, compiling, rectangle, and then here are all the rectangles sorted by their width. The reason sort by key is defined to take in fn mute closure is that it calls the closure multiple times, once for each item in the slice. Why does it need to be mutable? The closure r.width doesn't capture, mutate, or move out anything from its environment, so it meets the trait bound requirements. Okay. In contrast, listing 13.8 shows an example of a closure that implements just the fn once trait, because it moves a value out of the environment. The compiler won't let us use this closure with sort by keys. Alright, so here's sort by keys. Sort by operations.push value r.width. So value is just a string, the key being called. By key called. Sort operations is just a random vector. And we are using this, which mutates sort by operations. Oh, thank you. Just pretty prints sort of clearly things that aren't strings. Oh, yeah, thank you for that. I knew it was something with formatting. I thought, yeah, thank you for that. I did forget what that means. I wish it was just like :pretty or something like that. Something that we could tell easier. Alright. This is a contrived, convoluted way that doesn't work to try and count the number of times sort by key gets called when sorting list. This code attempts to do this counting by pushing value, a string, from the closure's environment into the sort operations vector. The closure captures value and then moves value out of the closure by transferring ownership of value to the sort operations vector. This closure can be called once. Yeah, it's hard to remember to type out all of this when debugging. You probably have a lot more experience with that than I do. Eventually I will just bash that directly into my head. Thank you again for clarifying that, though. This closure can be called once. Trying to call it a second time wouldn't work because value would no longer be in the environment to be pushed into sort operations again. Therefore, this closure only implements fn once. When we try and compile this code, we get this error that value can't be moved out of the closure because the closure must implement fn mute. Okay. Cannot move out of value. A captured variable in an fn mute closure. Value strings from key called. Right here is captured out of variable. Captured by this fn mute closure. Here's the place where it is captured. Sort operations.push. Move occurs because, type string, which does not implement the copy trait. Right, so yep, this is moving the value in because it cannot copy. Makes sense. The error points to the line in the closure body that moves value out of the environment. To fix this, we need to change the closure body so that it doesn't move values outside of the environment. To count the number of times sort by key is called, keeping a counter in the environment and incrementing its value in the closure body is a more straightforward way to calculate that. The closure in listing 13-9 works with sort by key because it is only capturing a mutable reference to the num sort operations counter and can therefore be called more than once. Alright, we have the same code here. We have this num sort operations plus equals 1. This is outside here and is simply iterated every time. This isn't taking in a value from outside and then attempting to utilize it within here in a way that cannot be copied. This is instead simply using 1, which can be copied and only exists within the closure anyway. Okay. Closures must name captured lifetimes. When you start designing functions that accept or return closures, you need to think about the lifetime of data captured by the closure. For example, here's a simple program that is supposed to return a closure that clones a string. Yep, so function make a cloner takes an sref, which is a string slice, returns an implementation of function. String move closure s.ref returned a string. So this will capture sref, but I don't think. However, this program was rejected by the compiler with the following error. Yeah, because we don't know the lifetimes. Hidden. Oh, okay, no. Hidden type for implement fn returning string. Sorry. Capture lifetime that does not appear in bounds. Okay. We have here hidden type closure at test.rs to 5 captures the anonymous lifetime defined here. Okay. Here. At this point. Alright, I'll admit, I don't know what's going on. The error might be a bit confusing. Yeah, exactly. What does this mean? I guess it's telling us it's confusing, though. I mean, at least we have a justification for confusion. What is a hidden type? Why does it capture a lifetime? Why does that lifetime need to appear in a bound? To answer this question, let's start by seeing what would happen if Rust allowed make a cloner to compile. Then we could write the following unsafe program. Okay. So we have the program here. We have make a cloner, which is just what we've written before. We have sown is string from hello world. And that cloner equal make a cloner, which is this, passing in a slice of the entirety of s_own. And we drop own and run the cloner again. Okay, so first off, we have s.own, the first location here. In the stack in main, sown is passed over to the heap with hello world. So we have a reference to heap memory hello world. It's been a while since we've seen this diagram. And then we have cloner, which is a variable, make a cloner from closure with a reference to heap memory hello world. At location 2, after we drop sown is deleted, and so is the heap memory. Undefined behavior, pointy used after is pointy is free. Yep, so that's a use after free error. Yes. Yep, so after we use it, it's a use after free. I understand that, but what in the world does a hidden type mean, and why does it capture a lifetime? I've never seen a function to make functions, and now I have to think about the lifetime of the function made by the function. Yeah, it's fucked. Hopefully this isn't common practice. Oh, it's definitely common practice, isn't it? I can see some use cases for this though, so maybe people are annotating it with comments to make it a lot easier to follow? No, they aren't. Let's follow the execution. After calling make a cloner, at level 1, or location 1, we get back a cloner. With closure is its environment, the reference sref. However, if we are allowed to drop sown at L2, then that invalidates clone, because its environment contains a pointer to deallocated memory. Then invoking cloner would cause a use after free. Returning to the original type error, the issue is that we need to tell Rust that the closure returned from make a cloner must not live longer than s_ref. We can do that explicitly using lifetime parameters like this. Okay? Yep, we've just said, hey, this has got to last for a longer time. These changes say s_ref is a string reference that lives for a by adding plus a to the return type's trait bounds indicates that the closure must live no longer than a. Therefore, Rust deduces this function is now safe. If we try to use it unsafely like before, Rust let's look through this. sown has write and ownership permissions. Cloner has write but not ownership. Sown has read, not write. Read but not ownership permissions. Cloner has read and ownership permissions. If we drop, we don't have ownership, so we can't drop it. Okay. Rust recognizes that as long as make a cloner is in use, sown cannot be dropped. It is reflected in the permissions. sown loses the O permission after calling make a cloner. Consequently, Rust rejects this program with the following error. Cannot move out of sown because it is borrowed. Borrow of sown occurs here. Move out of sown occurs here. Borrow later used here. Returning now to the original confusing error, the hidden type of the closure captured sref, which had a limited lifetime. The return type never mentioned this lifetime, so Rust could not deduce that make a cloner was safe. But if we explicitly say that the closure captures the lifetime of sref, then our function compiles. Okay. Yeah, make sure that what is passed in this function is still alive. Yep, that is the issue, but what does hidden type mean? This isn't descriptive of that. It's just saying, yeah, so it's a hidden type because it can't tell that it will live for the period of time necessary. That's just failure to add in a lifetime. That's not a hidden type, unless you're stating that the lifetime is part of the type. That might be what they mean. Note that we can use the lifetime elision rules to make the function type more concise. We can remove the generic as long as we keep an indicator. The return type depends on some lifetime like this. Alright. Yep. So this returns an implementation function which returns a string plus an empty lifetime, a generic lifetime. There is a lifetime. In sum, the FN traits are important when defining or using functions. I believe that's just a generic lifetime. I think that just means that it can use any specific lifetime and does not necessitate it doesn't need for us to tell it, hey, this lifetime is from this specific point here. That's my understanding of it. Since we only have one piece here, it can figure the rest out itself using lifetime lesions. If I'm wrong, I don't care too much, sadly. But I believe that is the way it works. Don't trust me entirely with this, to be clear. In sum, the FN traits are important when defining or using functions or types that make use of closures. In the next section, we'll discuss iterators. Many iterator methods take closure arguments, so keep the closure details in mind as we continue. Alright. We have a quiz of 4 pieces. Honestly, It's 9:30. I'm tired as hell. Yeah, I think that I'm okay with doing this next time. This has been fun though. I like closures. Thank you for being here, Sorbet, again. Always always awesome to have you in here. But I think this is about where we end. Once more, thank you for being here, but I'm going to leave. We'll do the quiz tomorrow, or in a week's time, we'll be doing this quiz. Hopefully, our minds will hold all this information in here. If not, we'll relearn it by it telling us how terribly wrong we were. Right? See you. Have an excellent day.